Welcome back. This is going to wrap our work on Unit 5, and I've decided since last time it didn't look like it showed you a whole lot of solver on that previous Excel look video, rather than share the Excel file, I'm going to share my desktop this time, and hopefully that gives you a better look at what pops up when we hit solver. So on the screen in front of you right now is the basic construct for our second travel with the Grateful Dead problem, where we're referencing X as the number of t-shirts and Y as numbers of sweatshirts. And again, I've taken the liberty of already entering some things into this particular set as we get ready to solver. We'll talk about that a bit when we get ready. Over here, you can find that cell E5 again is going to reference a solution for us in terms of how many t-shirts, and cell F5 is going to reference how many sweatshirts we should make. The objective function value that is $25 for each t-shirt added to $20 for each sweatshirt is housed here in cell E7. Constraints, I did put the ones down here that reference the fact that we don't want any negative values. You'll see them corresponding to X is greater than or equal to 0 and Y is greater than or equal to 0. But again, when we get down here to the left side, right side, you'll see that I have nothing for them. And I'll show you in Solver specifically where that click box is to guarantee us that values for X and Y remain non-negative. So what do we got? Well, we've got constraints relative to labor and constraints relative to space. We know that it took 30 minutes to prepare each t-shirt, took 15 minutes to prepare a sweatshirt, and that's minutes at 3360 that references 4 days of 14 hours a day. 56 times 24 should get us 3360. Second, relative to space, 2/10 of a cubic foot for each t-shirt, 5/10 of a cubic foot for each sweatshirt, and we have a max at 40 cubic feet in the van as we're getting ready to head out with the Grateful Dead. All right, let's fire this. Let's see how it goes. All right, punch data on the particular laptop for us here. Come on now. And over here, all the way on the extreme right-hand edge, you'll see that we're going to activate Solver. This time, hopefully, you'll get a better look at it. I saw on the last video, Solver didn't show up so well. Hopefully, it's showing up better now. And again, I've taken the liberty of entering some things, but I do want you to have the chance to play around with this a bit, see if you can make this particular form fit what you need to do for other particular linear programming problems. All right, first of all, on the top, where is your objective function cell? I've identified it here as cell F7. All right, so cell F7 is found by taking a certain value times another value and adding a value here times another value. So it's 25 bucks for each of these, and it's 20 bucks for each of these, and it's the sum of those. So tell Solver where your objective function is. We've got that. Where are your variables? Well, as previously noted, they're here in E5 and F5. So you can see I've entered information for my solver to know where the values are that it's going to be changing relative to helping me find a maximum value for that objective function. Constraints in play down here, left-hand side, right-hand side. Again, relatively easy to add these constraints. So your first click would be add, then it's going to ask you where the left-hand side is, and I simply click down here on E17. Then you get to choose the inequality that you want. I selected less than or equal to because that's what we were hoping for. And then it'll invite you to choose the right-hand side. So I clicked in here at F17, clicked add, and that entered that guy. And then I got an opportunity to enter a second guy that says the left-hand side here at E18 has to be less than the right-hand side, which is at F18. And down here, you can see already checked, make uncommitted variables unconstrained variables non-negative. So that's what we wanted. That takes care of these last two constraints kind of intuitively. I think we should go ahead and see if this thing's going to work. We're going to click on solve. If we're having a good day, it will find the values that maximize our objective function. In fact, create our biggest profit. Let's give it a rip. Congrats, it says we found it. I'm going to invite it to keep those solutions. So I'll click OK. And if we go back to the screen now, where previously there were no values, you now know that if, according to the processes by Solver, if we have 90 t-shirts along with 44 sweatshirts, that would get us a maximum profit of $3,130. And you know what? I do believe those are the values that we saw on a culminating slide on our PowerPoint. So good news for us. Solver seemed to be working well as it applied a linear programming solution to our problem dealing with t-shirts and sweatshirts and our potential Grateful Dead sale. So that will wrap down this video. As I said, I think it would be a good idea for you to pull this Excel file up, get some practice with it, see if you can make good things happen as it relates to these two examples, and then modifying the file as needed to create something that will solve something that you try to do as another linear programming problem. So I thank you for viewing, and we'll be back soon with videos for Unit 6. Take care.